Within this PE video, I want to talk to you about the concept of centre of mass. And actually, it's one of my favourite concepts in PE because it's kind of ungraspable. It's such an odd idea. Let me define it for you first of all. Centre of mass is a point in a body, so any object, point in a body where mass is distributed evenly, in all directions. Now, when I read that or when I hear it, I have to say it doesn't mean an awful lot to me. Let me write it in first of all, evenly in all directions. Okay, so it's not the most intuitive of concepts, but let's just kind of apply it to a kind of a stick man first of all. Let me draw my stick man. Here's Fred, badly drawn head has Fred, but here he is. Fred's got two arms, two legs, and he's standing ever so proudly over there. Well, first of all, let's identify where Fred's centre of mass is. It's around about his navel point. So it's around about the belly button. And what we're saying here is that if you take a measurement of mass in any direction from that point, it would be roughly even in all directions. Now then, I want to ask you a question. Well, what would happen if my man Fred, we'll draw him in a slightly different colour this time, if my man Fred, okay, this time he's risen one leg, and he's standing with his other leg there, and he's risen both of his arms. What happens now to Fred's centre of mass? And the answer is, well, it rises. It goes up. So if we raise our mass upwards, then the centre of mass will effectively move upwards. If we lower our mass, if we crouch, for example, our centre of mass will go down. Now, that might not seem to be particularly important, but when you start to think about it in an applied practical sense, it's actually very, very important. One of the things that you need to be aware of is that when we jump, for example, the flight path of our centre of mass is predetermined. I just want to say that one more time. The flight path, I'm actually going to write it in, the flight path of our centre of mass, is predetermined at takeoff, is predetermined. So, in other words, let's just imagine this person here, Fred's going to jump, so he's taken off here. This flight path of this centre of mass is going to be predetermined, and the centre of mass is going to land exactly there, and it can't be manipulated in the air. That centre of mass is predetermined, it's going to fly in that way. But imagine a situation where my man Fred hadn't raised his arm and knees at takeoff and his centre of mass had stayed low. Look what happens to that predetermined flight path. In other words, it travels less horizontal distance. So by raising your centre of mass, for example, a takeoff and a jump, let's say a high jump or a long jump event, you can actually increase the distance or the height that you travel. You'll also notice in my raised example, the peak height of the centre of mass's travel is also higher, so it actually allows you to jump higher. So manipulating the centre of mass is actually quite important. Now for a uniform object, something like a tennis ball or a shot from the shot put, the centre of mass of something like a ball is going to be bang in the middle. Of course, the mass is distributed evenly in all of its directions. So that's easy to identify. But in the human body, generally speaking, it's something like in the navel. For men, it tends to be slightly lower because, slightly higher because we tend to have broader shoulders and more weight at the top of our bodies. And for women, it tends to be slightly lower because hips in general tend to be slightly bigger in women than in men, and therefore there's more mass accumulated around the mid area of the body, so just bear that in mind as well. But this is actually quite an important point. So how does it relate to stability? Well, let's have a look at some points. I want to use the example of a headstand to show this. Well, first of all, point number one, we want to know about the points of contact. If we want our centre of mass to allow us to be more stable, we want to increase the points of contact that we have with the surface that we're balancing on. So in this case, look, we have 1, 2, 3 points of contact. So by having 3 points of contact, we are more stable. And also bear in mind that the centre of mass of this object around about here is directly over the base of support. So the second point is, if our base of support is below our centre of mass or a line of gravity, then we are more likely to be stable. And that should make sense, right? I mean, look, we have the base is there it is, and look, the centre of mass is positioned above that base, so we are stable. But there's something else about the base of support. Okay, the bigger the base, let me just get rid of that up there, bigger the base, we have greater stability. Okay, so in this particular performance, we might say to this performer, okay, if you're struggling to be stable, then perhaps what you need to do is you need to widen your base by spreading your hands and arms further, providing you a bigger area for your centre of mass to be positioned above. So by positioning the centre of mass above a wider base, we are more likely to be stable. Now, I mentioned something else a moment ago. I mentioned the idea of, and this is point 4, I mentioned the idea of the line of gravity. The line of gravity. Now then, we illustrate that a person's weight or their weight vector, their weight force, acts through their centre of mass. So imagine a situation where this performer had their centre of mass here acting downwards, but somehow they had their base of support over here. Okay, of course they would lean over and they would topple that way. They would be unstable. So we want the line of gravity coming through the centre of mass to be above the base of support. And my last point with relation to this is that the taller the object, or the longer the object, taller the object, the less stable it is. So, in this performance, this performer is actually making their body shape quite long and slim. It's quite sort of tall, isn't it? Okay, so if you're struggling to maintain balance there, the performer could quite simply bend their knees into here, bring their legs, and then finish there. In other words, they could lower the height of their actual performance. And you might have done this in your own gymnastics experiences. Bending the knees and bringing them down towards your chest actually allows you to become more stable. And there's numerous examples of adapting this technique, this headstand technique, when you sort of start out, when you're beginning to learn the headstand, where you can actually bring your knees downwards and make you more stable because you're less tall. There's less of your mass distributed up high above you, okay, in this inverted position. So in other words, these are 5 ways in which centre of mass impacts on our stability. And the final point I want to make is that only sometimes do we want stability. So sometimes we want instability. Because if you think about it, in sport there are effectively 2 types of techniques. There are techniques where we are in balance and we're stationary and we're not accelerating or decelerating, and we call those stable positions. Things like balances or ready positions would be good examples of those. But there are other times where we want instability. Think about, for example, a sprinter in the sprint start position. They want stability as they're in that position. Let me see if I can kind of do a vague drawing of that position. Oh, you've got the arms are like this, and then you've got one foot in here, coming down onto the block. So I drew that the wrong way. So you've got this here. Again, just let me get rid of this. Too many people are subscribing to the YouTube channel. I keep getting flashes up there. So we have this position, okay, in the sprint start. Well, of course, as soon as this performer lets go of their arms, they become unstable and they begin accelerating forwards. It's instability that the performer is actually trying to promote. So just bear that in mind. Sometimes we want the opposite of these things. We want to remove the points of contact. We want to remove the hand support from the ground because we're going to accelerate forward. We want to reduce the number of points of contact, make smaller the base of the support. We want to have a smaller base of support to decrease stability. We want the line of gravity outside the base of support so we accelerate forwards. And we want to make ourselves taller so we can begin to accelerate. Okay, so that's all on centre of mass and stability. Thanks so much for listening.